Melissa, is, so which period are you
B6.
in? B6, okay. So yesterday at A Day, I put all these flashcard decks on the tables. I would have a flashcard to make sure that you never forget the following. Let me show it to you. Right here. So I would have a flashcard that says this. Whenever I have to find a limit, the first thing I think of is what you were saying, which is I check to see if it's a limit as x approaches infinity. If it is, my eye is going to be drawn to locating terms that are adding, and hopefully I can compare those terms and identify which of the terms that are adding is most dominant.
Okay.
So when I look up here, I say, okay, x is approaching infinity. So you tell me, Melissa, name two terms in this expression that are adding.
Adding?
And subtracting is the same thing as addition.
Okay.
So
The 3 minus x.
good. So I compare the 3 added to a negative x. As x gets larger and larger and larger, will one of those two completely overwhelm the other? Meaning as you're adding them, one becomes very insignificant, the other one becomes extremely significant.
Yes, the x.
Perfect. So that means you can say this limit problem is equivalent to this limit problem. Instead of writing 3 minus x, I can just say, hey, negative x is going to dominate. I don't need to really consider the x once x is very, very large. What else could you say?
The 2x minus 1.
So which would dominate of those two additive terms?
The 2x.
The 2x. And what should I write on the bottom, Melissa?
X and then x.
Perfect. Does that feel okay?
Yeah.
Awesome. Okay, once I've done this, I look to factor. These are basically already factored, but if I write it out in a slightly different way, it becomes easier for me to see what's really happening. So I'm going to say this is really 2 over 1 multiplied by x over x, multiplied by x over x, multiplied by negative 1 over 1. So I just kind of wrote things out separately. Are you comfortable that what I've written is the same as this?
Yeah.
Awesome. So when x gets really, really large, what's this going to equal?
We'll equal 1.
Good. And this one?
1.
So when x is large, I can say, hey, really, despite the complexity of this computation, when x is large, really the end result is the y value is getting very, very close to negative 2.
Okay. That makes sense.
And then I would write another thing on your paper. I would remind myself that when x is approaching infinity and I find that the y value is getting close to negative 2, that means I have this kind of a situation. Here's my function f. Here's negative 2. I don't know what the graph does back here, so I don't attempt to say. But I do know that when x is very large, the graph's going to, in some fashion, get really, really close to negative 2, which means this function has a horizontal asymptote at y equal negative 2. It's critical that you always connect the finding of a limit as x approaches infinity to the fact that once you found that limit, you've also found the horizontal asymptote of the functions.
Okay.
Welcome, easy. Are we good? Cool.
Can we look at number 10?
Uh-huh.